here's a linear equation with fractions in it. So a linear equation is, with fractions, is still linear as long as the x's are in the numerators. Now when x's appear in the denominator, then it's no longer linear. In any event here, the secret in solving these, and I'm sure you've done these before, is to find a way to eliminate the fractions. And that's usually the easiest approach. Now we don't have to do it that way. We could combine these x terms together as fractions and then divide by the fractional coefficient. That would be okay. And it'd be a little messier. But the point here is to review this process of eliminating fractions in an equation. It's a common motif which runs through all rational types of equations and expressions. And by the way, we sometimes use the word rational in algebra because rational comes from the root word ratio, and ratio, of course, means a fraction. And so when you hear the word rational, think fractions. All right. So what is the secret here? The secret is to find the common denominator. And between 2, 3, and 6, our common denominator would be 6. That would be our least common denominator. So I'm going to multiply everything by 6. And by that I mean I'm multiplying the numerators by 6. I'm not multiplying the denominators by 6, only the numerators. And so just to show that, let me highlight that by recopying the problem. And then I'll draw the 6 in red here. So it means all these numerators are multiplied by 6. In other words, I distributed the 6 inside the big parentheses I created. Well, that leads to some nice things. And here the 2 cancels, leaving a 3. 3 cancels, leaving a 2. And 6 cancels altogether, leaving 1s. And so, well, all my denominators are 1s, so now I really have eliminated the fractions here. So what's left? I have 3 times 1. I have 3 minus 2x equals to 5x. And then now we're down to a much simpler linear equation. So this, in a sense, we've rescaled the problem. We've found a number to multiply which kind of rescaled it, changed the size so that fractions were no longer in it. That's sort of what happened here. If I add 2x to both sides, I get 3 equals to 7x, and divide by 7, x equals to 3/7. So now notice I did not write, whoops, I got a little error here, let me correct this. I divided by 7 both sides in order to cancel the 7s. I didn't write 3/7 equals to x. That's like speaking backwards. You know, rather than saying like, the car is green, writing 3/7 equals x is like saying green is the car. That's sort of like how Yoda spoke in Star Wars, for example. And so when you write your answer, rewrite it with the variable on the left. Because it reads like a normal English sentence, x equals to 3/7. That would be the polite way of writing that. Don't go to decimals on a small fraction like this. In the real world, you may need decimals as an approximation. Normally you do. And you can reach for a calculator and get 0.42 something, whatever that works out to be. But this is algebra, just writes a simple fraction. And there we go. So that's the answer there. And why don't we just show one more check here? I'll go ahead and check this while we have it up here, just to so you can see a little more practice with fractions in case you need it. And so to check it, I'm going to plug in 3/7. So I have 3/7 divided by 3 equals to 5 times 3/7 over 6. And It's a little awkward because we have some complex fractions here. Let's write it this way. 1/2 minus, this is 3/7 divided by 3. That means it's really 3/21. You know, 3/7 divided by 3 is the same as 3/7 times 1/3, which is 3/21. And here I've got 5 times 3 is 15 over what? 7 times 6 over 42. So I have 15 42nds. All right, so there you go. I'm still not done checking it. Let me make this look more like a 21. There we go. So it's a little bit awkward here. There's some other things you could do. We could cancel those 3's and cancel that 3. Could do it that way. And that would have given us what? That would have given us 1/2 minus 1/7 equals to 5/7 over 2 would be 5/14. So no matter how you look at it, this one's pretty awkward. But if I reduce these fractions, I'll get 1/7 here, I'll get 5/14 there. Let's go ahead and finish. My common denominator will be 14, so 1/2 is going to be what, 7/14, and 1/7 is 2/14. And indeed, 7/14 minus 2/14 is 5/14. So there you go, it's checked. A little messy, but you know, with a little practice, you get real fast at this and very confident in what you're doing, and you just make a lot less errors and you do better. So I would never discourage you from checking your answers. Okay, and I know again that sounds like it's very time consuming and it's a pain to do that, but yeah, if you don't want to do really well in this course, start checking your answers, and you'll find you'll start learning more about math that way, and you'll build your skills up so that you're faster at what you do. So I do think it saves time in the long run. All right, well, there's that problem.